Hello, dear students. You are welcome to our institute. I am Dr. R.K. Saini and today I am going to discuss entropy. For this purpose, I have chosen a question in which different processes are involved. Through this question, we will explain how to calculate entropy change for a process. Along with this, I will also explain some basic concept of entropy. Questions of this type are very important for JEE advanced examination. So, let's begin. First, we read question very carefully and then understand how many steps are involved in this question. First, we read question. Calculate molar entropy means entropy of 1 mole substance from 0 Kelvin to 600 Kelvin at constant pressure. Heat capacity of solid 0 Kelvin to. First, our aim to calculate entropy of the substance from 0 Kelvin to 600 Kelvin. The melting point, normal melting point at 1 atm pressure is 200 Kelvin, means solid melt at 200 degrees centigrade, or we can say at 200 Kelvin. Solid and their liquid are exist in dynamic form. It is the fusion entropy. And we know that the melting point of liquid is 300 Kelvin. It means solid change into liquid and liquid change into vapors, and further vapors or gaseous state further heating from 300 Kelvin to 600 Kelvin and 1 atm, and the essential data are given in this question. Now, in step first, we find following steps are involved in this process. First, solid at 0 Kelvin change into solid at 200 Kelvin, because 200 Kelvin is the melting point of the solid. Therefore, in step first, it is the heating of the substance. And in step second, solid at this temperature exists in the dynamic equilibrium state at their liquid, and it is the fusion entropy. And then further heating of the liquid in step third from 200 Kelvin to 300 Kelvin, because 300 Kelvin is the normal boiling point of this liquid, and hence equilibrium state also exists from liquid and their gas at 300 Kelvin, and it is the vaporization entropy change in step 4. And in finally, gaseous species or gaseous substance further heating from 300 Kelvin to 600 Kelvin according to given question. And hence in step first, the entropy change of the substance from solid to solid and change the temperature. According to second law of thermodynamics, we know that entropy is the exchange of heat energy. In given question, the heat energy at constant pressure and the given temperature. And constant pressure, we know that heat energy equals to enthalpy change of this temperature, and enthalpy of the substance is Cp dt divided by T, and the temperature range is T1 0 Kelvin to T2. The value of Cp of the solid is given. We check value of Cp at this temperature from 0 to 200 is 0.035 into T. Putting the value, Cp is given 0.035 into T into dt upon T. On solving, we find 0.035 into T2 minus T1. T1 is 0 Kelvin and T2 is 200 Kelvin. Therefore, entropy of step first change is 7 joule per Kelvin per mole in step first. Step second. Now in step second, it is known as fusion entropy of the substance, and we know that fusion entropy equals to fusion enthalpy upon fusion temperature. Fusion enthalpy upon fusion temperature. Fusion enthalpy given of the substance as this temperature, or the temperature is known as melting point, is given fusion 7.5 kilojoule. Therefore, 7.5 into 1000 divided by fusion temperature is 200 Kelvin, and hence the entropy change of this process is 37.5 joule per Kelvin per mole. Joule per Kelvin per mole. It is step entropy change in step second. Then in step third is also heating of the substance, and hence the delta S equals to delta H upon T, or delta H is Cp dt upon T, variation 200, temperature 200 to 300. Cp at this temperature of liquid given this 60 plus 0.016 T. It is the Cp dt upon T, and hence we find overall Cp change in step 4 is delta S step 4 or not third is 60 ln T2 upon T1, 60 ln T2 upon T1, and 0.016 dt T2 minus T1. T2 300, T1 200, and hence 0.016 into 100, and 60, and ln T2 300 or T1 200, and ln 1.5 is given. 1.5 given is 0.4. Therefore, 60 into 0.4, and this, and hence the entropy change in step third is 24 plus 1.6, or we can say 25.6. And then entropy change in step 4. Then we find entropy change in step 4. In step 4, it is also known as vaporization, entropy of vaporization. And the step 4 entropy of vaporization is enthalpy of vaporization upon vaporization temperature, means boiling point. Enthalpy of vaporization is also given. Vaporization enthalpy is given 30 kilojoule. Therefore, 30 kilojoule or joule divided by boiling temperature 300. And then step 4, the vaporization entropy change is 100 joule. 100 joule per Kelvin per mole. And step 5, and in step 5th, the entropy change of gaseous species is Cp dt upon T, and temperature vary from 300 Kelvin to 600. At this temperature range, the Cp of the gas is given 50. Therefore, 50 ln T2 600, T1 300, and ln 2 is given 0.7. ln 2 is 0.7. Therefore, 50 into 0.7 equals to 35. And overall entropy change of this process, ln 2, notice the value, ln 2 is 0.7. ln 2 is 0.7. And ln 1.5 is 0.4. Now, we find overall entropy change of the process by the addition of all entropy change in all steps. And hence, entropy overall net is sum of the entropy change step first, second, third, entropy change in fourth, and entropy change in step fifth. Entropy change in first step, we find entropy change in first step is 7 joule. Entropy change in second step is 37.5 joule per Kelvin. Step third is 25.6, and step 4 is 100, and step fifth, the entropy change is 35. Therefore, the overall entropy change is 205.1 joule per Kelvin per mole. It is the answer of this question, and we know some basic concept about the entropy. Thank you.